Hey everybody, and welcome to Chapter 6 of College Algebra. My name is Gregory Carlson, and Chapter 6 is all about analytic geometry. And what that means is we're gonna be combining the algebra we know with geometry, because it turns out that all those geometry shapes we're familiar with, like a circle, a parabola, a hyperbola, and ellipse, can all be described with algebraic equations. And so if you look at this table I printed for you in the notes, this table is a really good summary of pretty much all of Chapter 6. And each video we do is going to look at one specific section of this table right here. You should already be familiar with the circle, which we've already looked at in this class. And you know that it's x minus h squared plus y minus k squared equals r squared, where r is the radius, and hk, where you flip the two signs, that becomes the center of the circle. So you should already be familiar with how the equation of a circle is related to the circle. What we're going to do in 6.1 is look at parabolas. So here's all of the pieces of a parabola. You already know what a parabola is. It's something like y equals x squared. But there's something going on in the parabola that you might not know. Here's our parabola right here in blue, and we have our vertex right here. So what forms a parabola? It turns out that the parabola is a group of points. And inside of a parabola is a point called the focus. And kind of like, a satellite dish. If you have a satellite dish, the place that you put the camera or the microphone to pick up the readings from the satellite dish, they all get focused on this point called the focus. There's also a line on a parabola called the directrix, which is a line that just is on the opposite side of the parabola from the focus. So you have the focus and the directrix. And here's what here's why they're important. If you draw a line straight up from notice the right angle, so straight up from the directrix, hitting your parabola and coming to the focus, those two lines are going to always be the same length. And so what the parabola is, it's all points such that the vertical line from the directrix and the focus are the same length. So for example, this point right here would not be on the parabola, because if I drew a line up to here, that line would be longer than the line from the focus to that point. So the vertex is all of the points such that every time you draw a line up from the directrix, the line to the focus is the same distance. Keep in mind that the parabola will always surround the focus, okay? It will always surround the focus. Now, what is this distance? Well, it's actually very simple. We just call it P. So P is the distance between the focus and the vertex, and P is also the distance between the vertex and the directrix. Okay, so you're going to ask, where do we find P? Well, we're going to find that from the equation in a minute. So I hope that makes sense. So P is the distance between the focus and the vertex, and between the vertex and the directrix. And remember that the focus is inside the parabola and the directrix is kind of outside the parabola. So here's the formula for a parabola. It's y minus k equals a times x minus h squared. And remember that if it's y minus k, you need to flip the sign. Okay, that's what the minus means. Or you can add it over to this side. So for example, if it's written in this form, like pretend for a second we had the parabola y minus 2 equals x plus 3 squared. Say we had that parabola, y minus 2 equals x plus 3 squared. Well, that would be the parabola. The vertex is, you need to flip both the signs. So the vertex of that would be negative 3 comma 2 to flip both the signs. So negative 3, 2 would be right there. And your parabola, would kind of come up like this. So if the number is over with the y, you need to flip both of the signs to find the vertex, which would be this point right here, negative 3, 2. If we added the 2 over, we would get y equals x plus 3 squared plus 2. And so now you only need to flip the sign of the x, because the whole graph, y, is being bumped up 2 spaces now. So the vertex would still be at negative 3, 2. and you get the same graph. So these two equations are the same and the two graphs are the same. My point is, if the number is over here with y, flip the sign. If the number is on the other side of y, keep the sign the same, because that's the only way we're going to get the same graph from the same equation. So let's start with the easy ones. Let's graph with the easy ones, the ones you already know, and then we'll look at the focus and the directrix in the second video. So let's graph the following. As a reminder, you should already know this, but as a reminder, if we just have a regular x squared, it's over 1 up 1 in each direction from the vertex. So over 1 up 1, over 2 up 4, and over 3 up 9 in both directions from the vertex. Okay, so it's 1, 4, 9, and 1, 4, 9 from the vertex. So if it's just y equals x squared regular, that's through 0, 0. So it's over 1 up 1, over 2 up 4, over 3 up 9, and the same on the other side. And there's your regular old parabola, 1, 4, 9. And 1, 4, 9, 16, 25, and so on, all the square numbers. The domain of this would be all real numbers, because there's any x we can plug in. The range, though, remember, we can't plug in any, we don't get any negatives here. Everything's being squared, so we never get any negatives. So we go from 0 inclusive all the way to infinity. So that would be the range. We're only above the y-axis. The next one is negative x squared. That would just be the flip of this. So if you throw a negative in front, you just flip it down. So it's over 1 down 1, over 2 down 4, over 3 down 9. So the negative sign just flips the parabola down. Just like that. So what would the domain and range of this be? Well, once again, there's no restrictions on what we plug into it. So the domain is negative infinity to infinity. And this time, instead of the range going from 0 to positive infinity, the range is 0 to negative infinity. So it's 0 inclusive all the way down. So you see it's kind of the flip on the range. So what about this one? X equals y squared. So you should notice that something's weird because the y is being squared. And normally when we graph, we just have y equals. In fact, take a look what happens. It's positive, so this parabola is going to open this way. It's going to open to the right. So if it's up 1 over 1, up 2 over 4, down 2 over 4, up 3 over 9, down 3 over 9. So you see that this is not a function because it violates the vertical line test. But we're just looking at the basic forms. The 1, 4, 9 pattern's the same, except this time it's up 1 over 1, up 2 over 4, up 3 over 9. So what would the domain and range of this be? Well, this time the range is everything, because this graph goes up and down forever. So this time the range is negative infinity to infinity. And the domain would be, now notice, we don't have any x's over here. There's nothing to the left of the graph. So the domain would be 0 to positive infinity. Okay, so you see the domain and the range kind of flipped from this one over here. And that should make sense because these two are inverses of each other. They reflect over the line y equals x. So what do you think is going to happen with the last one if we have x equals negative y squared? Well, kind of like how this one flipped, this one's going to flip. So we start at 0, 0, and now it's over 1, up 1 to the left, over 2, up 4 to the left, over 3, up 3 over 9 to the left. So there you go. Once again, this graph goes up and down forever. So it's negative infinity to infinity on our range. But the domain has a restriction. There's no graph over here to the right. So the domain is negative infinity up to 0. Okay? So negative infinity up to 0 would be the domain. And so I guess I actually kind of did this one backwards, so I made a mistake right here. So the range here would be negative infinity up to 0. So I apologize for that. So in both cases, it's negative infinity up to 0 because we only have graph down here for the range and to the left here for the domain. But I believe everything else is correct, so just one little mistake. What's the takeaway from this? You need to remember the 1, 4, 9 pattern, and so on, 16, 25 for parabolas. And you need to know that if it's y equals x squared, we're opening up and down. And if it's x equals y squared, we're opening left or right. And if it's positive, we're opening up or to the right. And if it's negative, we're opening down or to the left. So in the next video, we'll graph these three and then look at how to graph the focus and the directrix. Luckily, it's not too hard. It's just a few steps you have to follow. See you in part 2.